Welcome to video 3 for this unit on two-variable statistics. In this video, we're going to focus on the correlation coefficient. While residuals can help pick the best line to fit the data among all lines, we still need a way to determine the strength of a linear relationship. Scatterplots of data that are close to the best fit line are better modeled by the line than scatterplots of data that are farther from the line. The correlation coefficient is a convenient number that can be used to describe the strength and direction of a linear relationship. Usually represented by the letter R, the correlation coefficient can take values from -1 to 1. The sign of the correlation coefficient is the same as the sign of the slope for the best fit line. The closer the correlation coefficient is to 0, the weaker the linear relationship. When the correlation coefficient is closer to 1 or -1, the linear model fits the data better. While it is possible to try to fit a linear model to any data, you should always look at the scatterplot to see if there is a possible linear trend. The correlation coefficient and residuals can also help determine whether the linear model makes sense to use to estimate the situation. The value for the correlation coefficient can be used to determine the strength of the relationship between the two variables represented in the data. In general, when the variables increase together, we can say they have a positive relationship. When an increase in one variable is paired with a decrease in the other, we can say they have a negative relationship. We say there is a strong relationship when the data is tightly clustered around the best fit line. The graph shows a strong, positive relationship. This graph shows a strong negative relationship. The data are tightly clustered around the line, and an increase in one variable's data tends to be paired with a decrease in the other variable's data. A correlation coefficient with a value near 1 suggests a strong positive relationship between the variables. This means that most of the data tends to be tightly clustered around a line, and that when one of the variables increases in value, the other does as well. The number of schools in a community and the population of the community is an example of variables that have a strong positive correlation. When there is a large population, there is usually a large number of schools, and small communities tend to have fewer schools, so the correlation is positive. These variables are closely tied together, so the correlation is strong. Similarly, a correlation coefficient with a value near -1 suggests a strong negative relationship between the variables. Again, most of the data tends to be tightly clustered around a line, but now, when one value increases, the other decreases. The time since you left home and the distance left to reach a park has a strong negative correlation. As the travel time increases, the distance to the park tends to decrease, so this is a negative correlation. The variables are, again, closely linearly related, so this is a strong correlation. Weaker correlations mean there may be reasons the data varies other than the connection between the two variables. For example, number of pets and number of siblings has a weak correlation. We say there is a weak relationship when the data is loosely spread around the line of best fit. This graph shows a weak, positive relationship. Humans are wired to look for connections and then use those connections to learn about the world around them. One way to notice connections is by looking for a pair of variables with a relationship. A causal relationship is a relationship in which a change in one of the variables causes a change in the other variable. One common mistake people tend to make using statistics is to think that all relationships between variables are causal. Scatterplots can only show a relationship between the two variables. To determine if a change in one of the variables actually causes a change in the other variable or has a causal relationship, the context must be better understood and other options ruled out. Let's look at an example. For example, we might expect to see a strong, positive relationship between the number of snowboard rentals and sales of hot chocolate during the months of September through January. This does not mean that an increase in snowboard rentals causes people to purchase more hot chocolate, nor does it mean that increased sales of hot chocolate cause people to rent snowboards more. More likely, there is a third variable, such as colder weather, that might be causing both variables to increase at the same time. On the other hand, sometimes there is a causal relationship. A strong positive relationship between hot chocolate sales and small marshmallow sales may be linked, because people buying hot chocolate may want to add small marshmallows to the drink. So, an increase in the sales of hot chocolate are actually causing the marshmallow sales to increase. Finding relationships with the help of the correlation coefficient is a very good way to notice that there is a connection between variables. To determine whether there is a causal relationship, the next step is usually to carefully design an experiment that isolates and precisely controls only one of the variables to determine how it affects the other variable. Thank you for watching video 3 of 3 for this unit on two-variable statistics.